Hey guys, my name is Frank and this is the Python programming video log. Today I'm going to show you how to program moving platforms for an HTML5 and JavaScript game using pure JavaScript without any libraries. If you learned something while you're watching this video, or if you use my code to do something in your own project, go ahead and give the video a like so it can move up in the rankings on YouTube and other people can learn how to do this stuff. Because I think everybody should be making games out there because it's way too easy and way too much fun. So also, go ahead and subscribe if you like the video because I'm making a whole bunch of videos like this, trying to make them pretty consistently, and it really helps me out. So go ahead, like and subscribe, and stay tuned to find out how it's done. So I'm going to assume that you guys have a little bit of understanding of how to get to this point that you see on the screen, how to draw a tile map and everything. I'm not going to go over that. I'm just going to go over the logic to move the player, to move the platforms, and to have the player be moved by a platform when he's standing on it. So basically, I'm going to make these platforms move. I'm going to make the player collide with them, and he's going to, interact with those platforms the way you would want him to in a game setting. So I'm going to come in here. The first thing I'm going to do is I'm going to say, let's add gravity to the player's velocity y and to his position. So let's say do.vy plus equals gravity. I define that elsewhere. It's just a numeric value. And then we're going to say do.y plus equals do.vy. Let's save that, refresh, and he falls like I expect him to. Okay, so the next thing we're going to do is add collision with the floor. Now this is really simple. We're just going to say if do.y is greater than floor. Once again, just a numeric value. The value for floor is going to be right around here. So what I'm going to do is I'm going to say if the top of the dude is greater than the value for floor, then do.y equals floor, that value for floor, and do.vy equals 0. So I'm setting his vy or velocity y to 0 whenever he collides with the floor. So what this is going to do is it's going to set his value as soon as the top of his head passes below about the area that my mouse pointer is. He's going to be set back to that position, and also his downward momentum or his downward velocity is going to be set to 0 right here. So that's what's going on there. The next thing I want to do is make him jump. So let's go ahead and come in here and say if controller.up do.vy minus equals 16. I'm also going to say controller.up equals false. This is going to prevent me from continuing to just boost him up by negative 16 pixels on every frame. Okay, so let's see what happens there. I'm going to press the up arrow key, and he jumps extremely high. Okay, all right, that's probably a little bit too high. I guess he'll come down eventually. We'll see. A little bit too high there. So what I'm going to do is I'm going to come in here, and I'm going to use his jumping value. So I'm going to say whenever he hits the floor, dude.jumping equals false. And I'm going to say if not do.jumping and controller.up. So if I'm pressing the up key and the dude is not jumping, meaning he's standing on the ground, then execute this code. Also in here, I'm going to come in and say do.jumping equals true. And I'm going to refresh. And let's see what happens now. He just jumps to that height every time. As long as I press the up key, he's going to jump that negative 16 pixels. Let's make this, instead of negative 16, let's make it negative 10. How about that? Okay, pretty good. Okay. Now let's do the left and right movement. So I'm going to say if controller.left do.vx minus equals 0. Let's do 0.75. If controller.right do.vx plus equals 0.75, and then of course down here I have to make sure I add his velocity x or vx to his actual x position. So do.vx, okay, do.x plus equals do.vx is going to add to his x position on every frame. So now I can have him move left and right, but there's no cap on his speed, so he can go really fast if I just hold the button down. And so we're going to have to add some friction in to counteract that. So now how we do friction in this example is going to be by subtracting it from the direction he's moving. So friction is the resistance to a force applied in the opposite direction. So if I'm moving over the ground to the right like this, friction would be a resistance to that motion to the right. So what I'm going to do is I'm going to do just that. Friction is going to be a value that's anywhere between 0 and 1. So 0.9 or 0.1, those would both be viable values. I'm going to come in here and I'm going to say if not dude dot jumping. So if the dude is not jumping, then we're going to have some friction. We're going to say dude.vx minus equals dude.vx times friction. So what I'm going to do now is I'm just going to show you friction. I'm going to come down to where I have some values defined here. For instance, floor, that's 116, so 116 pixels is right here. Friction is going to be 0.3. So, and also gravity is 1. So friction is 0.3. So what's going to happen here is on every frame of my animation, I'm going to subtract 0.3 times his current velocity x from his velocity x. So let's see what happens when I do that. I'm just going to come in here and refresh, and okay, looking pretty good there. Looking pretty good. It's a little bit different from what I normally do, just multiplying by 0.9, but basically this is the same thing. This is like multiplying by 0.7. So if I were to just say do.vx times equals, let's actually do that, times equals 0.7. Save that. Okay, so notice how the motion is now. And when I refresh, let's see if it changes at all. I think it's pretty much exactly the same. It should be, mathematically speaking, from my perspective right now. I may be overlooking something, but I think it's probably going to be exactly the same. So this is just a roundabout way of doing it. But basically what I'm doing is I'm saying do.vx equals do.vx minus 0.3 times do.vx. Now the reason I'm doing this is because this formula is going to be used, a similar formula is going to be used for calculating the resistance of friction between the moving platform and its momentum in either a left or right direction, and the player's momentum in either the left or right direction. So bear with me for now and just accept this formula until I can explain it a little better with the platforms. And we're going to go ahead and do those platforms. Let's just check to see what we have so far. So I have no friction when I'm jumping, so that's a problem. So let's go ahead and just get rid of, actually, let's see. If dude.jumping, we're going to do this. If the dude is not jumping, we're also going to do that. But since we have to have different friction for when he's in the air, on the ground, and on a platform, we're going to go ahead and just say when he is colliding with the floor, he's not going to be jumping, but do this anyway. Apply friction, and when he is jumping, apply friction. So we can do this, and now we have friction on the ground. We also have friction when we jump, so we get a pretty standard looking movement pattern for our player. Okay, so now let's go ahead and add some motion to the platforms, because that's probably what you guys are more interested in anyway. So I'm going to come down here inside the platform. Oh, wait, I think I skipped them. Okay, right here. So platform X. That's going to be this guy right here. So let's go ahead and do some movement for the platform X right there. I'm just going to come in here and I'm going to say platform.vx. Actually, I'm going to say platform.d. First, let's take a look at what the platform class actually looks like. So it inherits from the player class, and the player class basically just has some values in it. Let's actually go up and take a look at it. Player is going to have source X, source width, a behavior function that's going to be called on every frame. Now source X and source width is going to refer to the source X position and the source width of the tile image itself. So if I come in here and I actually come into my directory, click on platform.png, scale it up a little bit so we can actually see it. This is going to be the X position width-wise, and Y is always going to be 0 because this is the top of my image. So this is going to be the width, source width. This is going to be the source X. In this case, this will be source X, and this will be source width for this tile here. And I'll have one for the player as well. So that's what those do. They're just for cutting the image out of the sprite sheet. Behavior is just going to be the function. For example, for the dude object was the function I was just programming for him. It's going to be called on every frame. OX is old X position, old Y is old Y position. We're going to save that from the last frame of animation. VX and VY are going to be the player's velocity X and Y. That's going to be his X and Y momentum, basically. And of course, X and Y are going to be the player's position. So now let's take a look at the platform class itself. It has an anchor X and an anchor Y. Now, anchor X and anchor Y are just going to be where it starts out. So for instance, this would be anchor X and anchor Y for this platform. This would be anchor X and anchor Y for this platform. And this will be anchor X and anchor Y for this platform. In the case where they're all starting out, it would also be their X and Y, physical X and Y position that we're going to draw to. And they're all going to kind of move around their anchor point. So D is going to be a rotational value that we're going to base their movement on, and you'll see how I use that later. And width is just, this is going to basically determine, this is a Boolean value here. It's either going to be true or false. Is it big? Then it's going to be true. It's going to set up the values for source X and source width to draw this bigger platform. And if big is not set to true, if it's set to false, then we're going to be drawing one of these little platforms. So implement that however you will. This is just the way I did it. So anyway, now that you know all that, let's come down here. Came a little too far there. And just do some coding. So platform.d is the direction. So we're going to just add 0.01 to that. And then we're going to say platform.x equals platform.anchor x plus math.cosine or math.cos platform.d multiplied by, let's say 20. How about that? Let's refresh here. And now we have a platform that slides back and forth on the x-axis. Pretty cool. Not very far though, so what I'm going to do is I'm going to upgrade that to 40. It's going to make him go a lot farther. Let's see how that looks. Pretty good, not bad. Not bad at all. So for now, I'm going to leave this like this. The only thing is I'm going to have to add in the old X position to keep track of the old X position of this platform. So right before I set platform.x, I'm going to say platform.ox or old X equals platform.x. So on the previous frame, we're going to run through this code. The last thing that's going to happen is we're going to set platform.x. And on the very next frame, when we call this again, we're going to set old X equal to that old value for platform.x right before we update platform.x. So hopefully that makes sense. And that'll give us our current X position for the platform and the current or the old X position for the platform on each frame. So we're also going to do this for Y. Actually, Y for the x-axis platform never changes. So let's go ahead and do some collision, because right now, if I use the example, I don't have any collision. I'm just jumping right through the platform. So let's go ahead and do some collision. So I have down here, I have defined an array actually of platforms that I'm going to loop through to draw all my platforms down the game loop here. So each one of these platforms has a different behavior. Right now, the only behavior that I was coding was platform behavior X, so that's the one that's running right now. It's this guy right here. So I'm going to have to loop through all the platforms in this array inside of the dude's behavior, and I'm going to have to test to see if he's colliding with each one of these. So let's go up to the dude behavior and just do that. Let's see here. I'm going to do that pretty much right here. So I'm going to say for let index equal platforms.length -1, index is greater than -1, minus index. I'm just going to loop through backwards. It's just my preference there to loop through things backwards. Let's see, and we're going to say let platform equal platforms at index. So where we're looping through right there. And let's see. Let's test if dude.y is greater than platform.y. Actually, I have a value set up on the platform for the middle, but let's not do that for now. Let's just stick with platform.y. So if do.y is greater than platform.y, we're going to do the same exact code for the floor. So check out the code for the floor right here. We're basically going to do the same thing, only it's going to be for the platform. Do.y equals platform.y. And actually, we're going to have to do, well, you'll see in a second here. Do.vy equals 0. Do.jumping equals false. And I'm going to ignore friction for right now when we're on top of the platform. Let's see, platform is not defined. Let platform equal platforms. Okay, that was my mistake right there. Forgot to put an S in. All right. Oop, going a little too far there. Not sure what's going on here. So let's see what the problem is with our code. So basically, I'm looping through my platforms. I'm gonna, oh, I see what the problem is. I'm going for all of them. So I really need to just do this one. So I'm actually gonna be testing against these two. I totally forgot they were there because I was just thinking I was doing this one. Okay, so let's actually adjust again. So we're gonna have to test for the X position of the player against the X width and X position of the platform as well. We're gonna have to do that anyway. So let's just say if do.x is greater than platform.x and do.x is less than platform.x plus platform.width. I think I just have W. Or do I have W? Do I have left and right? I think I have left and right. Up here in platform, I'm going to come up here and just check real quick. Let's see. Nope. Let's see. Where am I at here? Oh, I'm in dude behavior, so I was going the wrong way there. So platform dot left and right is going to give me the left side of my platform, and right is going to give me the right side. Floor is actually going to give me the actual floor position of the platform. So let's just go with those values. If do.x is less or greater than platform.left, and if do.x is less than platform.right, then we're just going to do this if statement here. So save. Let's see what we get now. I'm going to jump. And you can see that the top of the player just sticks right to the, and it jumps to it as well because we're not testing for the old position as well yet. So I'm just going to go if do.x plus tile size times 0.5. Tile size is going to be half of the width and height of the player. So this is basically like saying if the far left X position of the dude plus half of his width, which will give us his center, is greater than platform.left, and do.x plus tile size times 0.5. So if the dude's X position plus half of his width, so basically his X center, is less than platform.right, we're going to run the code inside here. And then we're going to say if do.y is greater than platform.y and do.oy is less than or equal to platform.oy, then we're going to run this code right here. So the reason we have to do it this way is if, actually let me go ahead and just make this so he's actually standing on it, plus tile size. That's going to be his height as well as his width. And this is going to actually be, let's say, floor, because I already have a function to calculate the position of the floor of the platform. And old floor. So we're going to save. See what happens. Nothing happens. So if do.y is greater than platform.floor, okay, and do.oy, oh, you know why? Because I haven't actually set up do.oy yet. Okay, so here we go. This is where we're going to do this. Right before we change the values for do.y and do.x, we're going to say do.oy equals do.y and do.ox equals do.x. We're going to refresh, and we're going to jump on this platform. And he's kind of fallen through. And let me see what the reason for that is. I'm not entirely sure at the moment. Got to troubleshoot a little bit here. So we're going to say if dude.y plus tile size, so if the bottom of the player is greater than the platform's bottom, and the old bottom of the player is less than or equal to platform.oldFloor, then we're going to set, oh, that's why, platform.floor minus tile size. See what we get. All right, so now we are standing on top of our platform. I think if I get this right here, yep, I can stand on top of all of them. Okay, because it's testing for all of them. And once again, I'm standing up here. I don't have any friction applied. So I'm going to actually have to apply some friction to make him stay, because if I just don't touch the controls, it's basically going to slide right out from under me. Kind of like this. Because friction has not yet been applied. So in order to apply friction, we're going to have to compare the player's X and Y velocity with the platform's X and Y velocity. So let's go ahead and do that. But before we do that, we're going to have to give the platform an X velocity, at least for this one, because it's the behavior X, so it's just moving on the X axis. So what we're going to do is we're going to do this the right way, and we're going to say platform.vx is going to be a measurement between where we want the platform to be and where it used to be. So we're going to say where we want it to be, which is this code right here. This is where we want the platform to be. And we're going to calculate Vx by subtracting where it used to be. And then we're going to come in here and we're going to say platform.x plus equals platform.vx. So let's see if we get the same movement. Maybe I screwed up there. Looks like the same movement, but now we have set its X velocity or its X momentum. So how we did that was we just calculated velocity or momentum, and all that is just a measurement of where something was in one instance to where it is in the current instance or the next instance. So you subtract where it currently is, or where it used to be from where it currently is. So we're saying this is where we currently want it to be, and this is where it was on the last frame, so we're subtracting that away, and what remains is going to be the amount that has moved between frames, or its momentum. Now this is not going to be true momentum because we're setting it on every frame, so it's not conserving momentum from the last frame. We're just resetting it on every frame because this, we're not going to apply friction or anything to. It's just kind of on a track. It moves exactly a determined amount on every frame, and it's not really interacting with anything. The player is not going to affect the movement of the platform. The platform is going to affect the movement of the player. So the player does conserve momentum, and he is affected by forces of friction and gravity and everything like that. So let's come back up to the dude, because now we have some momentum or velocity for our platform, so we actually have something to compare to. And when he collides with the platform, we're going to go ahead and say dude.vx equals platform.vx minus dude.vx. Or actually, we're going to do plus equals, because we're never going to set our momentum equal to anything. We can only add and subtract forces to it. If we set it equal to something, I mean, we are technically going to set it equal to something, but we always want to add and subtract to momentum or velocity, because we don't want to just hard set it unless we're hard up against a wall and we're not moving anywhere. Kind of like when we hit the floor. There, it's okay to just hard reset your momentum or velocity to 0 because you're not moving anymore. You could do it this way, but there's really no reason to. So, all right, so we're going to do platform.vx, so the platform's momentum, minus the dude's momentum, and we're going to multiply that by our value for friction, which was 0.3. So let's go ahead and jump up there. And now, as you can see, the platform is actually pulling the player with it. Now, there's a slight delay because actually what's happening here, imagine this is just a box, and the player is just a box. We're just moving one box beneath another box, and the friction generated from that movement between two objects is going to pull the box on top of it. It might not pull it directly. It might not be 100% movement shared between each one. What that would look like would be this. If I multiply by 1, that is going to be 100% transfer of momentum there. So let me illustrate the difference here and show you what's going on. I'm going to come down to my friction. I'm going to set friction equal to 0.3. And this will give you that's probably too low actually, but whatever. Let's see what it does. Or actually, we don't even have to do that. Let's just leave that the way it is and come up here and just say, instead of multiplying by 1, let's multiply by 0.05. That's going to be a really, really low value for friction to have. So I'm going to jump up here. And as you can see, my player is still kind of moving whenever the platform slows down. It's almost like, imagine if the player was an ice cube or a ball, and you're kind of just moving a plank of wood beneath it, and it's kind of just getting very minimal friction, so it's just kind of just sliding on top of it, but still changing its direction based on which way you're moving that block of wood. So that's what's happening here. Basically, we're setting our value for friction, whatever we want it to be, and this is great if you want to use it for something like ice terrain or something like that where you can slide, you can control friction. But basically, if you want 0 friction or 100% friction and 100% transfer of movement, you could do 1. But that means your friction value is going to be really high, and you won't get that nice kind of slide to a stop effect when you're on the platform. It's just going to be really slow because friction is really high. So that's what it's going to look like. Now, if you were to want a simpler way to do this and totally avoid the whole momentum deal, what you would do is you would just say do.x plus equals platform.vx. So let me do that, and let's see what happens. Not quite full transfer there. Not really sure. Oh, you know what's happening? I know what's happening. I've totally eliminated friction, so that's what's happening. So what's going to happen here is I'm just going to say do.vx. I'm going to make friction the same as it was down here. So this is just our standard friction. So if I go ahead and just do this, he's not going to slide anymore. So that's going to be our standard friction. So now when I refresh, he's just going to stick directly to the platform, and there's going to be no friction applied, but he's just going to move with the platform. So that's a really simple way of doing it. It's going to make him stick directly to the platform, but his momentum is not going to be accurate because his momentum will not be increasing with the platform's momentum. So if you want to maintain accuracy in your player's actual momentum, then you're going to want to use the more complex method there that's commented out. But if you just want simple platform physics where your player sticks to a moving platform, this will totally suffice. You're just going to set the dude's X position. You're going to add to it just the platform's movement or momentum, and then you're going to just use the regular amount for friction to slow him down so he doesn't slide around on top of the platform. I personally think that having the accurate momentum for the player is a lot cooler. Might not be the best for your game physics, so you got to decide that. But this is what I prefer because right now, the way the code just was and what's running right now, my player's VX value is equal to 0, even though he's moving right and left. With this code here, when I refresh, his momentum is going to be equal to his actual momentum as he's moving on the screen. So it's going to be equal to basically the platform's momentum, and it's going to be equal to the platform's momentum plus his momentum when I'm moving him with the keyboard. So let's go back to friction here, and this is what we're going to stick with. So let's see what that looks like. Not bad. With our value for friction, he still slides a little bit, but really not that much. And in the air, let's see what happens in the air. He's kind of moving kind of too fast when he goes into the air there. Not sure what that's about, but we'll figure that one out. So what I want to do next is I want to add some basic movement to these other two platforms. So let's go ahead and say what this is going to do is for our next platform, and I'll show you what that does a little bit later. Actually, I probably shouldn't have put it in, but anyway, ignore that for now. I'm going to come down to platform.behavior_y. Basically, we're going to do the same exact thing for behavior x. We're just going to switch some values to make it y. So instead of ox, we're going to do oy. Instead of vx, we're going to do vy. Instead of platform.x, we're going to do y. So we're just coming through, replacing everything with y's, and bam. Now we have behavior for platform movement y. Cool. So now we have a moving platform. It's going to come back down and pick us up in a second here. When I jump on top of it, I'm moving right along with it. So now when it comes back down, I'm going to stick with it because I set the player's Vy or momentum Y equal to the platform's momentum Y. So this will be really evident if I speed up the movement of the platform. So let me do, instead of 0.01, let me do 0.05, refresh, see what that looks like. Now I'm going to come over here, I'm going to jump on, and you can see that I'm sticking right on the platform, even though it's moving pretty fast. Faster than the speed of gravity can pull me down, in fact. So if I come back up here, wherever that was, okay, let's say I just set it to 0, like I'm colliding with the floor. Let's see what happens if I do that. So I'm going to come over here, I'm going to jump on my platform, and on the way down there's a little bit of jitter, but not quite that much. So I'm going to come down here, I'm going to speed up the platform even further to show you guys what's happening. Actually, that might be too much. Let me just do 1. Actually, that's probably not enough. So let me do, oh, that's why. I got the wrong platform there. Let me do 0.1 for this one. Okay, there we go. So now that sucker is really moving. And on the way down, you can see that my player is kind of falling up off of the platform as he comes down. That's because we're not adjusting his Vy to equal the platform's Vy. So when I come back up here, instead of setting Vy to 0, it's going to be equal to the platform's Vy, and that's going to keep him moving right in sync with the platform. So no matter how fast it moves, he's going to stick right to it. Another cool thing about the adding momentum from the platform to the player is if I jump on the way down, I'm going to jump kind of short. Kind of like you would in real life. If you were standing on something that was falling down, you try to jump up off of it, you wouldn't really go very high because it's already falling out from under you. And by the same concept, if you were on a platform moving up very quickly and you jumped off at the top, you would probably gain a lot more height because you already have that stored vertical momentum from the platform. So you can use this almost as a springboard, which I think is a cool game mechanic to add to probably any game. So now lastly, let's go ahead, actually first, before I get to lastly here, let me go ahead and slow down that Y platform there. Just say 0.1. Give it a nice regular speed there. Let's go ahead and do this platform. It's the most interesting one, in my opinion. So let's get the X position and the Y position and combine them. There's our X. We're just going to literally copy this right from the other platforms. And there is our Y. So there's our X and Y. And let's go ahead and see what that looks like. Oh, I'll tell you why it looks like that, because I'm not adding anything to the platform's direction. Platform.d plus equals, let's say 0.01, just like the other two. Alright, so that's actually interesting. That's not what I was planning on, but that's actually pretty cool. So let's just jump on this and see what happens. So this is actually good that this happened, because this is a pretty cool direction for a platform to be able to go in a game. And you might actually want this. But as you can see, I can move around on the platform. I can jump between platforms, and everything is pretty good. I mean, it's pretty solid code right here. So let's go ahead and make this thing move in a circular motion. So I'm going to go ahead and come in here and say, let's see, oh, math.cosine. Actually, Do I want cosine? I do. I forgot to mention that for y and x, I'm just going to use cosine because check this out. If I use sine, let's see what happens. Actually, it should be exactly the same. Focus on platform.y here. I'm just changing this to sine instead. All right, there we go. That's actually more accurate. Notice how it started out from the center, and notice here. So let me refresh and notice where this guy starts out at. Starts out from the center. Now when I save this and I change it to cosine and I refresh, he starts out from the bottom. Now this is just due to the nature of the, I forget, polar coordinate or the unit circle. If you remember back to your geometry course, or I don't know what course it was, algebra, I forget which one. Anyway, this is just the nature of cosine and sine and how they translate between Cartesian coordinates and polar coordinates. So I'm going to go with sine because that's what y movement is all about. It's about sine. X movement is about cosine. Let's go in here and say sine for y, save. And now, since these are no longer the same function, cosine and cosine, we're not going to get this slanted movement pattern here. We're going to get a circle. So check this out. Nice circular moving platform. So right here in this example, I've covered pretty much all the different types of platforms you can want, just left to right, up and down. They have a nice movement pattern, I think, using sine and cosine waves. So I've got a big circle here. If you want an oval, just go ahead and come in here. I want an oval on the y axis. I want to shorten that up on the y axis a little bit. So now my platform is going to be more of an oval pattern here. It's going to move in a nice oval instead of that big circle. Actually, though, I think I do prefer the circle. So let's go back to the circle. Moves a little bit faster. It's a little bit more entertaining to watch, I think. So yeah, so that's how you program platforms and collision with platforms inside of a platforming game. Alright, so there is one more thing that I want to touch on before I close out this video. So that is the way the player just seems to fly off the edge of this platform here, and the other platforms for that matter, whenever he comes off of the platform. So if I come up onto this platform right here, give me a second to get up there. He's just going to really just fly right off the edge of this guy. You see how I just flew right off the edge of that? That's because friction is only being applied when he's on the ground, on a platform, or jumping, intentionally jumping. It's not applied just when he's in the air. So when he comes off the platform, he becomes airborne, and friction is just not applied to him, and he just kind of flies away in whatever direction he's going. So in order to combat this, what I'm going to do is kind of sloppy, but you'll probably understand what I'm trying to get at here. All you have to do is just keep track of if the player is airborne or not. So I'm just going to say var airborne equals true. By default, we're going to say airborne is true because we can test to see whether he's colliding with anything. And when he collides with the platform or the ground, we're going to set it to false. And in the case that it is true, we're just going to apply some friction. So let's go here. If the dude .y is greater than floor, he's going to hit the floor. Then we know airborne equals false. Okay. Then we're going to say if he's on top of a platform, also airborne equals false. Then to apply the friction, we're going to come down here where we apply friction to his velocity x, and we're just going to say if the dude is jumping or airborne, then we're going to go ahead and apply friction. So once again, this right here is what it looks like now, where he just kind of flies off the edge. Oh, wait. Just kind of flies off the edge right there, kind of sweeps down. And after we apply the change, this is what it's going to look like. He just kind of walks off like you would expect him to. He just kind of falls off. His speed doesn't dramatically increase, and it looks the way you would expect it to look. So that right there is a quick fix to that problem. I would suggest doing it slightly different, slightly neater, but that was a really quick sloppy fix for that problem in the video. Anyway, if you guys learned something or if you use my code, go ahead and like the video. Go ahead and subscribe to my channel so you can catch my next video, and I'll see you guys then in the next video. Have a good one.